AI broke the internet again, and this week has been absolutely insane. Kimi releases K3, the world's first open 2.8 trillion parameter model, the largest open model ever released, and it's already being used to run Kimi's own coding product end-to-end. Thinking Machines Lab releases Inkling, a 975 billion parameter MoE model trained from scratch on 45 trillion tokens across text, images, audio, and video, and they showed it fine-tuning itself inside its own coding environment. Sunday AI previews ACT2, a home robot foundation model that hit 99.1% zero-shot success on laundry folding across diverse unseen homes it had never seen before. Xiaomi releases a 38 billion parameter world foundation model for robotics that generates training scenes, videos, and robot policies all inside one unified model, with an 82.9 times inference speedup. Qualcomm AI Research releases MobileWan, the first 5 billion parameter video diffusion model that runs entirely on a phone, generating 5-second 480p video in 20 seconds on device. ADH Mass releases OUS OCR2, a tiny 0.8 billion parameter document parsing model that just topped the OmniDoc Bench leaderboard with a score of 96.58, the first end-to-end model to ever beat the pipeline methods on that benchmark. And Cactus Compute releases Needle, a 26 million parameter function calling model that runs at 6,000 tokens per second on a consumer device and a lot more. So, let's jump right in. First up, Kimi releases a genuinely historic new model this week. It's called Kimi K3, and this is a 2.8 trillion parameter model from Moonshot AI, making it the world's first open model to reach the 3 trillion parameter class. For context, for 9 of the past 12 months, Kimi models have set the upper bound of open model sizes. K3 continues that streak at a scale nobody else has publicly released. Now, here's what makes the architecture interesting. K3 is built on 2 new components they developed: Kimi Delta Attention and Attention Residuals. These change how information flows across sequence length and model depth. Combined with scaled MoE sparsity that activates 16 out of 896 experts per forward pass, and a framework called Stable Latent MoE, these structural changes yield roughly a 2.5 times improvement in overall scaling efficiency compared to Kimi K2. In other words, it converts compute into intelligence more effectively than before, not just more of the same. Now, for the benchmark numbers. Kimi is upfront that K3 overall still trails the most powerful proprietary models, Claude Fable 5 and GPT 5.6 Sol, but it shows frontier-level performance across their evaluation suite, consistently outperforming every other tested open or closed model except those 2. The specific area where the numbers are most compelling is kernel optimization. They gave each model up to 24 hours in a sandbox to profile, rewrite, and benchmark 4 real GPU kernel tasks across H200 and an alternative GPU vendor. K3 performed competitively with Fable 5 and substantially outperformed Opus 4.8, GPT 5.6 Sol, and GPT 5.5. And here's the part I find most interesting. In the late stages of K3's own development, an early version of K3 was used to handle the majority of the team's own kernel optimization work. In other words, the model helped build itself. That's a genuinely notable data point. K3 also has native vision capabilities and a 1 million token context window, supporting multimodal reasoning across images and long documents. Now, K3 is live today on Kimi.com, Kimi Work, Kimi Code, and the Kimi API. The full open model weights will be released by July 27th, 2026. A technical report with full architecture and training details will accompany the weights. Note that the benchmark comparisons are Kimi's own internal evaluations. Claude Fable 5 was evaluated by a third party and may include fallback behavior per their own disclosure. So take the competitive positioning claims with appropriate caution until independent evaluators run the weights. If you're interested in reading further, I'll link to this page in the description below. Also this week, Thinking Machines Lab releases a pretty impressive new open source model. It's called Inkling, and this is a 975 billion total parameter mixture of experts model with 41 billion active parameters, trained from scratch on 45 trillion tokens of text, images, audio, and video. It supports up to 1 million tokens of context. Now, Thinking Machines Lab is a smaller, independent lab, and their explicit positioning is really refreshing. They're not claiming this is the best model overall. They say flat out that Inkling is not the strongest open or closed model available today. Instead, they're positioning it as a strong open weight space, specifically designed for fine-tuning and customization. And to show what that means in practice, they ran one of the coolest demos I've seen in a while. They asked Inkling to fine-tune itself. inside their own coding platform called OpenCode. Inkling wrote its own fine-tuning job, ran it through their Tinker API, and evaluated the result. The target behavior was a lipogram model that never uses the letter E, something that prompting alone can't reliably achieve. Inkling drafted the plan, generated synthetic training data, kicked off the fine-tuning run, loaded the new weights, and verified the result all by itself. That's a pretty wild loop to close in a single demo. In terms of actual capabilities, it covers agentic coding, tool use, multimodality across text, images, and audio, controllable thinking effort, and what they specifically call epistemics, which is the model's ability to express calibrated uncertainty rather than just confidently being wrong. They also release Inkling Small alongside it, a preview of a lighter version with 12 billion active parameters trained on the same recipe. Now for your reference, Inkling sits in the top tier of open weight models on their benchmark suite, but specific head-to-head numbers against Qwen 3.5 or Lave OV2 were not published in the main blog post. The model card has more detail. The awesome thing is they've released this already under Apache 2.0. Weights are on Hugging Face, and it's available for fine-tuning right now in their Tinker console with a free playground for developers to test it. If you're interested in reading further, I'll link to this page in the description below. In humanoid robot news, we have two pretty significant releases this week. First up, Sunday AI previews ACT2, which is their home robot foundation model built for their Memo household robot. And the headline number here is genuinely impressive. ACT2 achieved 99.1% zero-shot success rate on laundry folding across diverse, unseen home environments it had never trained in. Now, you see, in robotics, there's a long-standing tension between generalization and reliability. Training on diverse data makes models general, but their behaviors aren't necessarily reliable. Narrow, curated data produces performant policies, but those gains stay tied to the environments where the data was collected. ACT2 is designed to break this trade-off. The key finding is that as pre-training scales on diverse data, the generalization gap between in-domain and out-of-domain performance closes. And past a certain pre-training scale, a single fine-tuning example can teach the model a new behavior that transfers, not to environments like the training data, to environments it has never seen at all. For your reference, they ran a controlled experiment showing this. At smaller pre-training scale, post-training gains stay mostly within the in-domain environments. At their full pre-training scale, those same gains generalize across new homes at a significantly higher rate, and that matters for the product side. Because ACT2 learns so efficiently from single examples, Sunday can close reliability gaps quickly as failures surface in real homes. Identify a failure pattern, collect one example, post-train, generalize. That's a fundamentally different maintenance curve than what most robot deployments require. Sunday says they'll begin deploying Memo into beta homes this year, starting a physical world scaling loop that feeds data back into ACT3 and beyond. If you're interested in reading further, I'll link to this page in the description below. Also, Xiaomi releases a pretty fascinating new open source world model for robotics. It's called Xiaomi Robotics U0, and this is a 38 billion parameter autoregressive world foundation model that unifies 5 completely different tasks inside a single model: text-to-image generation, image editing, multi-view embodied scene generation, embodied transfer, and embodied video generation. Now, the reason this matters for robotics is the data problem. Getting enough diverse, high-quality training data for robot policies is incredibly expensive. Xiaomi Robotics U0 is designed to generate that data synthetically at scale. Given a language description of a scene, it can generate multi-view robot observations of that scene. Given a robot demonstration in one environment, it can transfer that demonstration to look like a completely different environment, with different lighting, textures, and object layouts, without recollecting any real data. And then, using those generated scenes and transferred demonstrations, it can generate entire robot video trajectories, which can be used to train downstream robot policies directly. Now, the number that stands out most is the inference speed. Their FlashR Plus inference system converts what was a 450-second latency per 1024 by 1024 image down to 5.44 seconds, a near 83 times speedup, while preserving the same generation quality. That speedup is what makes the data generation pipeline actually practical. For your reference, generating policies trained on their synthesized data achieves state-of-the-art results on both single-step and sequential embodied generation benchmarks. The awesome thing is they've released this already. The weights and code are on Hugging Face and GitHub under an open license. This is from Xiaomi Robotics Lab with a technical report on Archive. If you're interested in reading further, I'll link to this page in the description below. Next up, Qualcomm AI Research releases a pretty significant new model. It's called MobileWan, and this is the first time a 5 billion parameter video diffusion model has ever been deployed on a mobile device, end-to-end, running entirely on the phone without any cloud. Now for your reference, here are the actual numbers. MobileWan generates 5-second 480 by 832 video at 16 frames per second in 20 seconds of end-to-end latency on a commercial mobile device. It achieves a VBench score of 83.79, which is the new state-of-the-art for on-device video generation. And in a user study, people preferred MobileWan videos 80% of the time over the previous best on-device method, NeoDragon. Now what makes this possible is the compression approach. Starting from WAN 2.25b, the team converted the attention into a chunk-wise autoregressive RNN at inference time, so the model generates video chunk by chunk with near constant peak memory instead of attending over the entire video at once. They then added causal linear attention for temporal coherence across chunks, a learnable head pruning method using binary per head gates to remove attention heads that aren't contributing meaningfully, and aggressive sampling step distillation to cut the number of denoising steps needed. The result is a server-scale model running on a phone without visible quality degradation compared to the full server model. The awesome thing is they've released the weights and training recipes already on Hugging Face and GitHub under an open license. This is from Qualcomm AI Research. If you're interested in reading further, I'll link to this page in the description below. Also this week, we have a really impressive new open source document parsing model. It's called OUS OCR2, and this is a 0.8 billion parameter model that takes a page image of any document and outputs a clean markdown representation of the full page, covering text, formulas, tables, figures, and captions, all in correct reading order, in a single end-to-end pass. Now, for the benchmark numbers. OUS OCR2 achieves an overall score of 96.58 on OmniDoc Bench v1.6, which is the standard benchmark for document parsing quality. That's a new state-of-the-art. And here's the really impressive part. It's the first end-to-end model to ever reach the top of that leaderboard, which was previously dominated entirely by multi-step pipeline methods, systems that chain together an OCR model, a layout detection model, a table extraction model, and a reading order model, all separately. OUS OCR2 replaces all of that with one 0.8 billion parameter model in a single pass. How this works is it's built by post-training QWEN 3.50.8b on a carefully designed data engine that combines real-world and synthetic documents, trained through a multi-stage recipe of SFT, reinforcement learning, and something they call OPD. Now, can you run this on a consumer GPU? Absolutely. At 0.8 billion parameters, this runs on basically any modern GPU. It's one of the lightest models I've covered in a while for what it does. The awesome thing is they've released this already under Apache 2.0. The weights are on Hugging Face under 8th mass OUS OCR2, and the code is in the OUS GitHub repo. If you're interested in reading further, I'll link to this page in the description below. And finally this week, we have a genuinely tiny but pretty fascinating new model. It's called Needle. And this is a 26 million parameter function calling model from Cactus Compute that runs at 6,000 tokens per second on a consumer device. Now, you see, function calling is actually the backbone of every agentic system. Whenever a language model decides to call a tool, it needs to match a query to a tool name, extract the argument values, and emit the right JSON. That's it. It's fundamentally a retrieval and assembly task, not a reasoning task. And the team at Cactus had a pretty simple observation. Massive general-purpose models are overkill for this. Tool calling doesn't need FFN parameters to store facts, because the facts are provided in the input as the tool schema. Cross-attention is the right primitive, not a full transformer with MLPs, so they built Needle as a pure attention and gating architecture with no FFN layers anywhere. The entire model is attention and gating only. They pre-trained it on 200 billion tokens across 16 TPU v6e chips in 27 hours, then post-trained it on 2 billion tokens of synthesized function calling data generated by Gemini, covering 15 tool categories like timers, messaging, navigation, and smart home in 45 minutes. For your reference, on single-shot function calling, Needle beats Function Gemma 270M, Qwen 0.6b, Granite 350M, and LFM 2.5 350M, despite being dramatically smaller than all of them. In terms of raw speed, it runs at 6,000 tokens per second prefill and 1,200 tokens per second decode on consumer devices, which is fast enough for real-time on-device agentic experiences on phones, watches, and glasses. Now, to be fair, those larger models have broader conversational scope. Needle is a specialist for single-shot function calling only. It won't replace a general-purpose model for anything requiring reasoning or knowledge, but as the tool routing layer of an agentic system running on device, it's extremely interesting. The awesome thing is they've released this already under MIT license. The weights are on Hugging Face, the code is on GitHub, and there's a web UI playground at localhost you can spin up in a few commands. If you're interested in reading further, I'll link to this page in the description below. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite? And which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So, if you enjoyed this video, remember to share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So, to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.